Hello everyone. So we're continuing still with our topic of reinforced concrete structures. This little video will be about columns. Let's get started. Lovely. So thank you so much for being here. I appreciate your time. Columns, this is what we're going to be talking about. I hope I can show it to you with these images that I'm showing on the screen. We're looking at these elements that are made of columns, and for the most part they're fully vertical. Okay, that's what we're going to be playing around with today with this video. They're covered in your textbooks under chapters 21, 22, 23, and a little bit, I guess, in the appendix 2, and I'll link that item as well with some of the information in the description of your video. For the most part, what are columns? Columns are kind of those elements that are expected to behave in compression. Okay, so I'm showing here an example of what I mean by compression. It's called compression, that kind of force that's causing whatever structural element you're looking at to become shorter. If you apply a force on an element and that element becomes shorter or shorter, that is compression. For the most part, columns are primarily in compression in structures, and they're primarily vertical, okay, for whatever that definition of vertical is. They're kind of considered also the funnels of structural elements, and that's because not only do they support the floor or roof that's attached to them, that's what columns do, they also support the column above. And that column above in turns is supporting the floor or roof attached to it. But that column above is also supporting the column above it, and so on and so forth. So the further down a structure you are, the more that column is supporting, because not only is it supporting the floor attached to it, it's supporting the weight of all the columns and floors above it that are funneling down their way to that column. Okay? The purpose of columns basically is to transfer a building's loads, and we've learned what loads are, to the foundations and footings, and therefore to the soil below the structure in the building. We're going to talk about reinforced columns construction and a little bit about the reinforcing, that is the steel layout within a column. We'll start with the so-called longitudinal steel. This is the steel that I'm showing here on the screen, and you can see also on the right hand side how it's created on site, the cage for it, that goes the length of the column. Longitudinal steel. Now, columns can be very tall, right? So you can't get necessarily pieces of steel, longitudinal steel, that are the full length of the column. So sometimes you have to double up, right? Lap the steel by a certain length to make sure that you can make the whole length of the column. The other steel that we're going to talk about is the ties, and you can see them here on your screen on the left and also displayed on the right. The ties can either be individual ties, or they can kind of be set up as spirals that go up the length of the column, and they're meant to cage in the longitudinal steel, keep it in place, as well as resist shear in the columns, because that's what we learned about ties in our previous video. The longitudinal bars are there for compression, tension, a little bit of bending, but for the most part they're compression, and the ties are meant to hold the steel in place as well as resist shear in columns. So once you've created the reinforcing, you place it on site. So kind of like you see here on the right hand side, either you fasten it to the reinforcing of the column below or to a footing and foundation below. Then, as we've learned, because it's concrete, you have to form it. So here you see an example of a square or rectangular form. You pour the concrete into this, or you can have circular columns with these kind of forms that you see on the screen. And finally, you obtain the final product, right? You let the concrete cure long enough. After you've properly placed it, you remove the forms and you have your final product. Concrete reinforcing can be set out in very different ways, but for the most part it follows the same pattern. You can see here, this concrete basically, this is kind of section cut out, a slice cut out of the concrete column. You have a tie with then rebar, longitudinal rebar placed at the corners and halfway between the corner rebars. This is the kind of setup that you'll see typically if the rebar is spaced no more apart than 6 inches. So that's about 150 millimeters. You'll see this kind of layout if the rebar is spaced more than 6 inches apart. So more than 150 millimeters apart, you'll notice that middle longitudinal bars are actually also tied together with either a cross pattern or a diamond pattern. And finally, for a rectangular column, you can have this kind of layout. This here is in the figure that I took straight out of your textbook, so go check it out. I also want to point you towards the concrete sketches that I've posted for you for assignment 2. They have a lot of good information about the rebar layout. That's both in elevation and in section. So go check that out. I'm going to link it for you in the description below. Now, the one thing that I want to talk about now is concrete cover. And I don't mean the kind of covers that you use on a bed, right, to cover yourself, although the topic is relatively similar. What I mean by concrete cover is this. You know how with a cover, you basically cover yourself if you're in bed, either because you want to block the light or stay warm, right? You're adding a layer between you and the outside, right? The room. Well, it's kind of the same thing with concrete reinforced concrete structures. So here's the thing. Concrete cover is the amount of concrete that you put on top of the outermost layer of reinforcing steel. So like right here. The idea is this. Reinforced concrete has to be exposed often to the elements. So that's rain, snow, wind, pooled water, salt maybe from ice prevention techniques. And because concrete is designed, for the most part, to be somewhat porous, that is that water can go through it, when water goes through it, it can carry salt with it, but it can also get on top of that reinforcing steel that's close to the surface. And if that happens, and it happens often enough, then you can get rusting of that reinforcement of the steel. And when rusting happens, this chemical reaction happens that gets the rebar to expand and crack the concrete. So depending on where you are in the world and the kind of weather conditions you have to weather, or the use of your structure, reinforced concrete structure, you have to add a thicker or thinner layer of concrete on the outsidemost steel to cover your concrete and minimize the possibility that water or any other agents can affect the rebar and cause it to deteriorate, to rust, and therefore negatively affect your structure. So that's what concrete cover is that minimum thickness of layer that covers the outermost steel reinforcing. In your textbook, in table 22.1, you can actually find the minimum requirements for concrete cover depending on the use of your structure. Okay, so go check it out. The other thing too that I think is important is sometimes the best way to figure out how concrete columns, reinforced concrete columns are built is to do it yourself or to watch somebody else do it. So I've linked for you 2 videos in the description below that do exactly that. Now these are not meant to be authoritative videos, but they do kind of show you how this is done, okay? Short of me posting a video of a job site where this is happening. So I'll link those for you below. Furthermore, I also want to remind you that I'm going to link for you below the video that I created about sizing reinforced concrete columns. And that's part of a bigger video that I've made for you about sizing reinforced concrete elements, again, linked for you at the bottom. The next topic that I'd like to talk about is punching shear. That sounds very interesting, punching shear, right? So let's start with what I have on the screen for you. I have 2 images. The image on the left shows columns attached to a slab above it, looks like reinforced concrete. It is reinforced concrete. On the right, you see columns attached to a slab above it, all reinforced concrete. The main difference is this. The main difference is this. Pardon me for that. The columns the columns on the left do not have what look like the same hats on top of them that the columns on the right do. Right? Can you see on the right, those columns seem to have kind of like a hat that's attaching them to the slab above it? Now, here's the thing. Why is one built that way and the other one isn't? Well, punching shear is the issue. If your columns are spaced far enough apart, too far apart, and the weight of the slab and the loading on that slab is enough, your slab will fall, come off, and your column will punch through the phenomenon of punching shear. And this happens, right? And the way to prevent it is either you put your columns closer together and or you add so-called drop panels, which you can see on the image on the right. I took that straight out of your textbook. Drop panels are there to basically allow the concrete to increase the surface area of the concrete as it gets closer to the slab. So basically the area of the column is constant, either circular or rectangular. But as you get closer to the slab above it, the area of the column is expanded much wider. And that's what the drop panels do. They expand that area so that more of the force from the slab is transferred on a bigger area, and you have more difficulty causing punching shear. I also provide details on the design of drop panels, so they're linked for you below. But I want to explain to you another way of looking at this, okay? If you see on the image on the right, you see one person that's about to step on one nail. That's a problem, because you know what's going to happen, right? It's not going to be pleasant. It's going to be very painful. But the person on the right is actually walking on a whole bunch of nails that are very close together. And what's happening is this. On the left, all of that weight is going on one nail. A whole bunch of force on a very, very small surface area. That nail is going to punch through the skin, the same way that a column punches through a slab. On the right, because those nails are closer together, the weight of that person is carried over many, many nails. And that's why if you put columns closer together, you won't get the same punching through effect. Alternatively, if you put hats on top of the columns, because you're spreading the load on a bigger area, you also prevent punching shear. And that again, as I said, I'm going to link for you in how to design drop panels in the video that is linked below. That's it. I want to thank you so much for your time, and I hope this has been of assistance to you. Take care.